Welcome back on my channel. Today we will continue ray optics and optical instruments class 12th okay chapter, and we will continue that, and the subtopic is refraction at a spherical surface. Okay, we will continue. uh, we have we have so far considered refraction at a plane interface. We shall now consider refraction at a spherical interface between two transparent media. An infinite small part of the spherical surface can be regarded as planar. Okay, and the same laws of the refraction can be applied at every point on the surface. Just as for reflection by a spherical mirror, the normal at the point of incidence is perpendicular to the tangent plane to the spherical surface at that point, and therefore passes through its center of curvature. Okay. We first consider refraction by a single spherical surface and follow it by thin lenses. Are you getting? A thin lens is a transparent optical medium bounded by a two for image formation by a single spherical surface successively at the two surface of a lens. We shall obtain the lens maker's formula and then the lens formula. Okay. Now refraction at a spherical surface. Are you getting? So quiet and listen quietly. In figure 9.15, okay, and figure 15 is this is the figure. Okay, this is the figure. Okay, and we will continue in this figure. Okay, so that the geometry of the formation of the image 1, image I of an object O, the principal axis of the spherical surface with the center of the curvature C and radius of center radius of curvature R. The rays are incident from a medium of the refractive index n1 to another of the refractive index n2. As before, we take the aperture or the lateral size of the surface to the small compared to other distances involved, so the small angle approximation can be made. In particular, nm will be taken to be nearly equal to the length of the perpendicular from the point n on the principal axis. We have for a small angle tan NOM equal to MN upon OM. Okay, and we are talking about in this figure. Okay, listen carefully. Tan NCM equal to MN upon CM. Tan NIM is equal to Mn upon Mi. Now for NOC, I is the exterior angle, therefore I is equal to angle NOM plus angle NCM. I is equal to Mn upon OM plus Mn upon CM. Okay, this is also equation. Similarly, R is equal to angle NCM minus NIM, therefore I is equal to Mn upon MC minus Mn upon Mi, and by this is also equation. By Snell's law, n1 sin I is equal to n2 sin R, or for a small angle ni, because sin will come on ni, n first I equal to n2 R. Is it? Substituting I and R from equation 9.13 and 9.14 in the from this both equation, n1 upon Om plus n2 upon mi equal to n2 minus m n1 upon mc. This is also equation. Here Om, mi or mc represent magnitude of the distances applying the Cartesian sign convention. Om is equal to minus u, mi is equal to plus b, mc is equal to plus r. Substituting these in the equation, n2 upon v minus n1 upon u equal to n2 minus n1 upon r. Okay, this is the equation also. Okay, and this equation gives a relation between object and the image distance in terms of refractive index of the medium and the radius of the curvature of the curved spherical surface. It holds for any curved spherical surface. अगर समझ में आए तो लाइक और सब्सक्राइब जरूर करिएगा, मेरे आपसे ये सब्र निवेदन है।